of these trig functions today. So far we have talked about the derivative of sine, cosine, and tangent. If I look at this problem, so what would I have to do to calculate this derivative? Product rule, yeah. You have two things being multiplied, they both have the variable, the t in them, so we have to do product rule. So derivative of the first, derivative of 2 is just 0, minus 3 times the derivative of cosine. What's the derivative of cosine? Negative sine. So minus a negative makes it just a positive 3 sine of t times the second plus the first times the derivative of the second. What is the derivative of e to the t?
E to the t.
E to the t.
So just like e to the x.
As far as how to simplify this, there's really not much. You could distribute if you wanted. But that is as far as we can go. That would be our answer.
Yeah, that one's kind of confused.
How is that e to the t again?
Remember we had a rule that said if you have e to the x, the derivative is still e to the x. That's if it's e to any variable, so the t just took the place of that. So that was just a rule that we had in the last section. Other questions? Okay. Get this one. Write an equation of the line tangent to the curve y equals cosine squared x at the point P on the graph where x is pi over 4. So equation of a tangent line, we need a point and a slope. What do I need to do? Derivative to get the slope. Now, be careful. Y equals cosine squared x. That just means y equals the cosine of x squared. Now if it's just plain x to the second, we can bring down the power and go like that. But it doesn't work that way if you have something on the inside. We will get to some other rules to help with that. For now, when you have cosine of x squared, you need to think of that as cosine x times cosine x. So to do that derivative, we have to do the product rule. So derivative of the first, derivative of cosine, is negative sine times the second plus the first times the derivative of the second. Derivative of cosine is negative sine. Okay, these are both negative sine x, cosine x, so if you add them together we get negative 2 sine x, cosine x. Just adding like terms. Okay. So now to get my slope, we have to go ahead and plug our x in here. So we have negative 2 sine of pi over 4 cosine of pi over 4. What is the sine of pi over 4? Sine of 45 degrees, which is 2. Cosine of pi over 4. So if we multiply these, we get -2 times the square root of 4, so -2 times 2 is -4 over 4, which is -1 for my slope. My point, the x is pi over 4. To get the y, if you plug that in, cosine of pi over 4 is radical 2 over 2 times radical 2 over 2, and that gives us 2 over 4 or 1/2.
Wait, what was that last step?
Okay, to find the y value, because all I gave you was the x of the old pair. I plugged pi over 4 into the original. So cosine of x, cosine of that is radical 2 over 2 times radical 2 over 2. So you get the square root of 4 over 4, which reduces to 1/2. So now if we plug into y equals mx plus b, it's not pretty, but it works. So our y-intercept is 1/2 plus pi over 4. So the equation y equals m, so -1x plus b, which is our 1/2 plus pi over 4. A little uglier than our typical line, but it'll work. Any questions there? So what I want to talk about now is the derivatives of the other trig functions. We've done sine, cosine, and tangent. We can get the others in much the same way. For instance, if I wanted to find the derivative of secant. We know secant is just 1 over cosine, right? So we could do the quotient rule like we did yesterday. Low, d high, derivative of the top is 0, minus high, d low, derivative of the bottom, negative, over low squared. So this gives me 0 plus sine x over cosine squared x. Cosine squared is the same as cosine times cosine, right? So we could think this is like a 1 over cosine, which is a secant, and a 1 over, and a sine over cosine, which is a tangent. So the derivative of secant turns into secant x tangent x. If you look on the next slide, I have that right here. Derivative of secant is secant x tangent x. We've already done sine, cosine, and tangent yesterday. We could do cosecant and cotangent the same way, quotient rules, and you get similar results. You'll notice the derivative of all the cos is negative. Cosine, cosecant, cotangent, all those derivatives are negative. Otherwise, they follow similar patterns. Tangent and cotangent both turn into something squared. Derivative of tangent is secant squared. Derivative of cosecant or of cotangent is negative cosecant squared. Derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. You really need to know these rules. At the very least, you have to know the derivatives of sine and cosine. The other 4 you could work out by doing quotient rule. It's just going to cost you a lot of time in the long run. So if it were me, I would make myself 6 flashcards and start studying these. You really want to memorize them it will save you a lot of time and headache in the future. Do you want me to prove the two that I haven't so far? Cosecant and cotangent? Want me to work out either of those? So what I want to do now is just practice a few more derivatives involving these other functions. Why don't you guys take a second and see if you can do this one on your own? The derivative of x. So if we have x times tangent x, what would we have to do for this derivative?
He didn't write. He didn't do it.
Product rule.
Yeah, lazy.
Derivative of the first. You guys are so mean. Derivative of the first would be 1 times the second.
Wait, why do you
Oh,
have
and you put a zero.
turn it into the secant thing?
I haven't done the derivative of tangent yet. I'm doing
The
product.
x is still a 1.
Plus the first thing, so that's my x, times the derivative of the second. Derivative of tangent is secant squared. So you just get tangent x plus x secant squared x.
Oh, it's an X?
I was just trying to turn it.
See, I was pretty much right. I just meant.
I messed up.
I don't know why I put 0.
How'd you both
I don't
put
know
zero?
why. I was thinking it was just a regular number. I don't know why.
Yeah, I put 0 too. Connor gets one question right. Yeah.
All right, let's talk about b. If I have cotangent cubed, how am I going to have to write that? 3 times. This means you have cotangent of t times cotangent of t times cotangent of t. So we have to do the product rule, but we will have 3 things. So you do one derivative at a time. Derivative of the first. What is the derivative of cotangent? Negative cosecant squared x. And the other two stay the same. Plus, the next one, the first one stays the same. Derivative of the second one, negative cosecant squared. You guys said x, and I changed my t's to x.
I'm
No,
sorry. See, I knew.
It's your fault.
Every variable should just be X.
Yeah.
Yeah, I know.
I
It
agree.
just makes
I'm sick of
everything
these
easy.
T's.
Because the T's look like the cotangent, and then there's
Yes.
a T, and it looks like a plus, and it just throws everything off.
So that's A plus T on the end? What is that, A?
No, this is a very sloppy cotangent of t. Then the last one, the first and the second stay the same. But the derivative of the third one is negative cosecant squared t. If you multiply these, you get negative cosecant squared cotangent squared. Plus negative cosecant squared cotangent squared. Plus negative cosecant squared cotangent squared. So what does this turn into?
3, a negative 3.
Negative 3 cosecant squared t cotangent squared t. Let's keep doing these. I have secant of z divided by the square root of z. Or you could think of that as secant of z over z to the 1/2. So what do we need to do? Quotient rule. So low, d high. What is the derivative of secant?
Secant. Or Z.
Secant X.
My variable is z. Secant z, tangent z. Minus high, d low. Derivative of the bottom.
1/2 Z.
Cool.
over low
Oh, shit.
squared. So you have z to the 1/2 secant of z tangent of z minus 1/2 secant, I'm going to write that as 1/2 z to the negative 1/2 secant of z over z. Is this proper notation? No. We've got several ugly pieces here. We have the fraction and a fraction. We also have the negative exponent on top. There are some different approaches we could take for cleaning this up. One option, we know in a fraction it's legal to take the top and bottom times the same thing, right? So if you want to cancel that 1/2, you could take everything times a 2. If I want to get rid of that z to the negative 1/2, we can multiply by z to the positive 1/2. When you multiply, you add exponents. So you get 2z, 1/2 plus 1/2 is just 1. Minus 2 times a half, that cancels. Z to the 1/2 and z to the negative 1/2. That would be z to the 0, which is just 1, so those cancel. On the bottom, 1/2 plus 1 would be 3/2. So unlike, remember when we did the derivatives of polynomials, the answer usually got prettier every time. With these trig functions, a lot of times your derivative is going to be uglier than your original function. All right, I want to just keep trying some of these if we can. Let me just practice a little bit more. Do you guys want to try this one on your own first? Why don't you? So low, 1 plus tangent x. D high, what's the derivative of secant?
Secant x tangent.
Minus high. D low, what's the derivative of 1 plus tangent? Over low square. If we distribute, we get secant x tangent x plus secant x tangent squared x minus secant cubed x over 1 plus tangent x squared. And that's your final answer.
Oh, let's go. You get that right?
Yeah. Alright. Let's try a few more.
Okay. I can't read my book.
I know that. You have improved a lot since like freshman year.
I was circling it all day.
Okay. An object at the end of a vertical spring is stretched 4 centimeters beyond its rest position and released at time t equals 0. So you've got a spring, you stretch it, and then you let go. The position is given by this equation. Find the velocity and acceleration. What is velocity? What's acceleration? Alright. So I think I gave you room on the next slide to actually work this out. So our first derivative, since 4 is just a coefficient, do we have to do product rule? No, it just stays. So it's 4 times, what's the derivative of cosine? Negative sine t. So you just get negative 4 sine of t. That's your velocity. Okay. Second derivative would be what? Negative 4 derivative of sine is cosine, and that is the acceleration. And I didn't ask you to find it at any particular moment in time, so that's all we have to do. Last one for today. Find the 27th derivative of cosine x. That'll be fun. So, the first derivative is what?
Negative sine of x.
Second derivative. The negative cosine x. What's the third derivative? What's the fourth derivative? Do you notice anything?
Just like those.
We're back to the beginning, right? So this would be the 5th, the 6th, the 7th, the 8th, the 9th, 10th, 11th, 12th. So there is a pattern here.
Did I say out loud?
So which one would we be on when we get to 27?
Yeah.
Since we have that pattern, we don't have to keep calculating it over and over again. Alright. Is that okay with everybody? So here is the plan. The bulk of the homework problems you are ready for. If you look, all the last part of these notes have to do with limits. So we are going to wait and we are going to do those in a couple days. So we are ready for the day 2 homework. You will have a work day tomorrow. Then Thursday I will teach the final.